Hey class, this is Mr. Roberts coming to you from Shasta High School, and at the request of students, I'm trying this black background white text for this recording. Apparently it's better if you're looking at these videos later at night. So I'm going to go through the Chapter 6 test, walk through every single question. Again, skip forward if there's only particular questions that you need to look at. My intention here is to record one video per page. So there were only 3 pages on this test, so let's look at page number 1. The first question says, consider the equation y equals 12x minus 4y. I'm sorry, 12x minus 4y equals 18. There, I said it correctly. The question is, what is the slope of this line? The slope of this line. Well, one of the things that makes it easy to recognize, identify the slope of a particular linear relationship is to write that linear relationship in the form y equals some value m times x and then plus b. This value m, right, the coefficient of x, turns out to be the slope. It's one of the 2 parameters. The 2 parameters for any line are the slope and the y-intercept. So what I'm going to do is I'm going to solve this equation for the variable y. That means I need to get y completely alone. Once it's in that form, y equals m times x plus b, I can more easily identify the slope. So to do that, I'm going to begin by taking away 12x from each side of this equation. That's going to become, on the left-hand side, we'll just have the 4y, and that will equal a negative 12x and then minus 18. So again, you see what I've done is I've subtracted this from both sides. When I take it away from the left-hand side, it's gone, and then on the right-hand side, you can see there is a negative 12x when I subtract it from that side. So equal things minus equal things gives me equal things. Now I'm going to divide both sides by negative 4, and I'm going to be very careful to make sure it is a negative. When I do that, on the left-hand side, there's just one term, and that becomes y. On the right-hand side, I'm going to get negative 12x over negative 4, and then minus 18 over negative 4. So the only thing that I care about is this coefficient of x, right? The numerical value that x is being multiplied by. And I can see that that is equivalent to negative 12 rather, divided by negative 4. And negative 12 divided by negative 4 is equal to just plain old 3. So for this question, the slope is just positive 3, although I just said negative 3. Negative 12 divided by negative 4 is positive 3. That's my slope. Notice there's no x there. X is not part of my slope. X is the variable that's driving, it's one of my 2 variables that's driving the input-output. My slope is just 3, up 3 units and over 1 unit. Next question, number 2, it says find the equation of the line that goes through this particular point, this point with an x value of 8 and a y value of 5, so x comma y, and is perpendicular, makes a right angle with the line negative 3x plus 4y equals negative 4. Well, I know that perpendicular lines have slopes that are opposite in sign, meaning if one's positive, the other's negative, and vice versa, and they are reciprocals. So I need to know what the slope of this particular line is in order to write the equation line that's perpendicular. So let's figure out the slope of this one first of all. Again, I'm going to do the same thing I did in the previous equation. I'm going to rewrite this equation in the form y equals mx plus b, and then I'll be able to easily identify what the slope is by considering that coefficient of x. So we'll write 4 times y is equal to positive 3x minus 4. So if you look, what I did from the first equation to the second was I added 3x to each side. Equal things plus equal things gives me the equal things. And now I'm going to divide both sides by the number 4. So I get y is equal to 3/4 times x and then minus the number 4 over 4, which is equal to 1. So the thing that I really need from this is, what's the slope of the line I'm given? It's 3/4. And since I'm looking for lines that are perpendicular, the slope that I'm going to be using for my answer is going to be negative in sign and reciprocal 4/3. So we're looking at this negative 4/3 is the slope that we're going to have to use. It's not my answer, but it's the slope of my answer. What I need to do now is I need to figure out the other parameter. I know my slope parameter m now is going to be negative 4/3. I need to figure out what my y-intercept would be. And to do that, I'm just going to take this y equals m times x plus b, and I'm going to plug in the x value. You can see here x is the number 8, and I'm going to plug in the y value, and y was the number 5. I'm going to plug those points in, and I'm also going to plug into my equation the value of my slope parameter, negative 4/3. So the equation is going to become, let's see, y, which is the number 5, and that equals, m, which is negative 4/3, there's that slope, times x, which turns out to be the number 8, so negative 4/3 times 8, and then plus b. So in this equation, the only thing that I don't have is the value of b. So I'm going to solve for b, and then I'll know, yay, my y-intercept. Well, it's not the prettiest thing in the world, but let me simplify it one step. 5 is equal to 4 times 8 would be negative 32 thirds, and then plus b. So I'm going to add 4 times 8 is 32. So I'm going to add 32 thirds to both sides. So I'm running out of room here. Let's write, I'll just bring this up to here. So that's going to be a 5 plus 32 thirds equals b. So if I want to convert 5 into thirds, right? 5 into thirds is going to be 15 thirds. So I have 15 thirds plus 32 thirds is b. So that means that b, my y-intercept, is going to be at 47 thirds. That's not a bad number. If you struggle with those kind of fraction manipulations, practice, it'll get better. One of the things you can do is, take a look at your calculator. If I've got 5 and I add to that 32 thirds, right, I get this thing. And then if I ask my calculator, what is it, I can hit math and turn it into a fraction. It tells me it's 47 thirds. So while you're practicing and getting good, right, don't let that get in the way of doing actual mathematics, right? Just develop your arithmetic skills. But I definitely can see what the y-intercept is. So my answer here is going to be y is equal to negative 4 thirds times x, and then plus 47 over 3. So that is the equation of a line that has two properties. It is both perpendicular to this line that I was given. It's perpendicular to this line, and it goes through this point. All right, let's move on to question number 3. Ooh, okay. It says, consider this sequence that goes from 6 to 3 to 3/2. Okay, well, as I look at that, I can see every single time it's half as much as the previous term. In other words, I'm multiplying by the number 1/2 each time. 6 times a half gives me 3. 3 times 1/2 gives me 3/2. So the next thing it says is write the next 4 terms of this sequence as fractions. So not bad, right? Because I'm just going to be putting an extra factor of 2 in the denominator each time. So the next term should be 3. And then I had a 2 that last time, but if I go 2 times another 2, it's going to be 3/4. And the next one is going to be a 3, but with another factor of 2. 4 times another factor of 2 would give me 8. And then I've got a 3, and another factor of 2 would give me 16. And I still got the 3, and another factor of 2 would give me 32. So these are the next 4 terms in the sequence. What is the sequence generator? What is the generator of the sequence? Well, good. The operation is multiplication. Multiplication. by 1/2. What kind of sequence is? Well, because its generator involves multiplication by a constant, right? This kind of sequence is called a geometric. As opposed to a sequence in which we're adding the same thing, adding a constant each time, that would be an arithmetic sequence. But this one is geometric because we're multiplying by 1/2 each time. And then finally it says write an explicit formula for this sequence. So the explicit formula, is generally of the form a of n equals a 0th term. I don't know what variables they use for these in our book, but I'll just write the word 0 term. So what's the 0th term of the sequence? And then times the multiplier, and then raised to the nth power. And the reason why we're doing this is, remember, exponentiation allows us to multiply by this 1/2 again and again and again and again. My first term in the sequence was the number 6. So if I need the 0th term, I have to go back to what happened before that. So that would have been the value 12. So my 0th term is 12. My generator is multiplied by 1/2. So we're looking at this for our answer, right? A of n is equal to 12 times 1/2 raised to the nth power. So regardless, all I have to do is I have to tell it which term number I want. I plug that in for n, and it will tell me what the sequence would equal at that point. And just to kind of show you big picture, this right here is this was the first, second, third, fourth, fifth, sixth, seventh. This is the 7th term. And just to show you how this works, let me grab my calculator here, clear it, and I'm going to go ahead and go 12 times 1/2. I'll just do 1/2 like this in the parentheses, raised to the 7th power. So when I do that, I get this lovely decimal, and if I want, I can hit math frac, turn it back into a fraction. I can see, yeah, it's absolutely the number 3/30 seconds, 3 over 32. So you can see when I plug in n is 7, it gives me 3/30 seconds. This would be 6. If I plug this one in, this would be the 5th term. I can just go up and grab this equation again, doop, and I can change this from a 7. I'll change it into a 5. When I do it, I get this decimal, and if I kick that into a fraction, you can see I get 3/8. So yeah, the 5th term, when I put in 5 into this equation, it's giving me 3/8. So it's nice to kind of confirm that the equation you've written down is doing what we're intending it to do. All right, last question on this page has 3 expressions. We're asked to write in simplified form. Again, what does that mean? First of all, you can't have any giant ones left behind, and you're not allowed to leave negative exponents in your final answer. When I look at this, I can see that there is a 3 that's not being raised to a power and a 5 that's not being raised to a power. So I know there's definitely going to be a 15 that's part of my answer. The other thing that let's look at is I can see here I've got an x to the negative 2nd and an x to the 7th power, and when I multiply those together, right, that's going to leave me with 5 factors of x. So I can just write this down as x to the 5th power. -2 plus 7 is +5. Another way to think about this is of course 1 over x squared, and if I multiply that by x to the 7th power over 1, you can see it becomes x to the 7th over x squared, which is again x to the 5th power. So lots of ways you can see that, but I end up with 5 factors of x, and they all live in the numerator. And then the final thing that I have here as part of this answer is the y's. I've got a y to the 8th and a y to the -3rd. That's simply going to be y raised to the 5th power. So my answer there is 15, x to the 5th, y to the 5th. Let's move on to B. In question B, this 6, this whole expression right here, this 6 times x is being raised to the negative second power. So both of those are being raised to the negative second. So I want to go ahead and clear that negative exponent first, and actually I'll probably deal with this negative exponent at the same time. So the rational way that we talk about, the logical way that we talk about clearing negative exponents is by multiplying by the number 1. So if I was to just clear just this y to the negative third, I could multiply this by y to the third over y to the third. Big story picture here is, what am I multiplying by? 1. And of course, the identity property of multiplication tells me that if I multiply by 1, I'm not changing the value of this problem at all. I'm just changing how part of it looks. And then in this numerator now, you can see I've got a y to the negative third and y to the third, which gives me just y to the 0, which equals the number 1. So what happens is I can rewrite this as 6 times x to the negative second times a 36, and then times an x to the fifth, and then there's a times a 1, and there is also a y to the third that lives in my denominator. So that cleared that negative exponent. And a similar argument I can make for this 6 times x raised to the negative second. I'm not going to make that argument. I'm just going to write down the fact that this is now a 6 times x raised to the positive second power after I do that. So this has changed how it looks quite a bit. I think in some ways it's looking simpler because there are no more negative exponents, but we're not quite done. Let me just rewrite it again to clean this up a little bit. So I've got a 36x to the fifth, and the denominator there is this y cubed. Now if I square x, or 6 times x, right, that's a 6 times an x times another 6 times x. 6 times x squared gives me 36 times x squared. So what I'm looking at now is I have a giant 1 in the form of 36 over 36. So that's gone. And the other thing that I have is, when I simplify this x to the fifth and this y, or the x to the fifth and the x to the second, that's just going to give me x to the third power left over in my numerator, and in my denominator I have a y to the third. So the final answer for this one is x cubed over y cubed. And then the final problem on this page, again, simplify this expression. I think a problem I saw many students make was they just saw this y and a 4, y and a 4, and they just assumed this was a giant 1, and it's not. Right? We have to clear that. That pin's too large. Let me make that a little bit thinner. So I'm going to clear this negative exponent by multiplying this by y to the fourth power over y to the fourth power. Again, this equals 1, so I'm not changing this problem. I'm just changing its form. When I do that, this y to the negative fourth times y to the fourth becomes just equal to 1 itself, because it's y to the 0 power. So this becomes, in the numerator, a 3, I don't know why I'm writing in red now, it becomes a 3 times x to the fifth, and in the denominator I've got this 15, there's an x squared, and then I've got this y to the fourth and another y to the fourth, which is y to the 8th power. And yeah, you see I forgot to write the 1 for the 15. 3 over 15 simplifies, right? There is a giant 1 there. And I'm going to write that too. So this is 3 over 3 times 5 times an x squared. In my numerator, I've got this x squared times an x cubed. I just chose to rewrite this x to the fifth power, and the reason why is so I can see the giant 1 clearly. And then don't forget that there's a y to the 8th that still lives in the denominator. So what can I get rid of? Well, this turns out to be the number 1. 3 divided by 3 is the number 1. And also this x squared over x squared is also the number 1. So the only thing that I'm left with in my answer is, in the numerator I've got an x cubed, and in the denominator there is a 5, and there is a y raised to the 8th power. So that was the answer to part C, and that's the end of page 1.